Today we'll be deriving the formula for the angle of twist for simple torsion. So we start out being given that alpha equals 2 times the moment times the original length over pi times the radius to the fourth times g. So here we have the object, from which we could take the two equations. The arc of AB equals gamma, which is the shear strain, times L naught, which is the original length. And we could also take that the arc of AB is equal to the radius times alpha. We could put these two equations together, equating them to each other. And from the original equation, we also see that a g is involved, which means that we have to relate this to this concept in this equation. So we take that the modulus of rigidity, which is g, is going to be equal to the shear stress over the shear strain, which is equal to tau over gamma. So when we rearrange that, we have the modulus of rigidity is equal to the shear stress over the shear strain, and then we could we could turn that into the shear strain is equal to the shear stress over the modulus of rigidity. So after we have these two equations, we have to take out a cross-sectional area from the object because there's a force being applied to it. So that gives us that tells us that we're going to have to integrate. So we're going to take the torque total is equal to the integral from 0 to r of 2 pi tau times r squared. However, from before, we could derive that tau is equal to the modulus of rigidity times the radius times alpha over L naught. So then we take the integral. So then we plug that into the integral, and we're given that the moment is equal to the integral from 0 to r of 2 pi times g times the radius times alpha times r squared over L naught dr. We could remove the constants outside of the integral, leaving us only to integrate an r cubed. Integrating the r cubed, we're given r to the fourth over 4, which gives us that the moment is equal to 2 pi over g alpha r to the fourth over L naught times 4, simplifying and finally bringing us to our equation.